My name is Shirish Rawan. I work for United Nations Office for Outer Space Affairs based in Vienna, Austria. So first of all, I wish good afternoon to all participants from Asia. Good morning to all colleagues from Europe and Africa. And I think also good morning to Americas, but I think it's almost midnight or a dawn there from, but I know some of the participants are joining from USA, Mexico, and some places from there. So I welcome all. Specifically, I work for United Nations platform for space-based information for disaster management and emergency response, UN Spider. I just want to make sure, Patrick, am I audible and all good?
Loud and clear.
Okay, great. Right. So I welcome all the participants and panelists to this webinar on space-based inputs for Locust early warning and preparedness. This webinar is co-organized by United Nations Office for Outer Space Affairs, that is my office, and International Water Management Institute based in Sri Lanka. We popularly call it IWMI. So IWMI is a regional support office of UN Spider program of UNOOSA, the United Nations Office for Outer Space Affairs. That's our association with IWMI. I just take 1 minute for housekeeping rules. It's very simple. All the participants and speakers, I'm requesting them to switch off their camera and mute microphone. Otherwise, it will disturb the speakers. For the speakers, whenever they are speaking, they can switch on their camera and microphone, and when they finish their intervention, they should close it. I think this is the only simple housekeeping rule. I will also tell about questions little later, but I would like to now officially begin the webinar. This webinar is our attempt to responding to a crisis within crisis. Now, what all of us know that world is struggling to cope up with COVID-19 outbreak, which has already pulled several countries into recession. And the unprecedented desert locust storm are adding to this crisis by creating a risk of food security and hunger. So this is a timely gathering and intervention that would help the authorities and farmers to respond to this crisis. Although few webinars are already conducted on the locust outbreak, this would be the first one that focuses on the space technology inputs on locust early warning and prevention. We have with us excellent panelists from China, India, Pakistan, World Bank, World Food Program, and also Food and Agriculture Organization. They all have enormous experience in supporting the fight with the voracious pest that threatens the food security of millions. They will cover a range of topics from providing us the facts about locust to the application of space and other high technologies in the effort related to early warning, preparedness, and damage assessment. Specifically from International Water Management Institute, Dr. Giriraj Amarnath has worked me as a co-organizer. So I thank him for being with me for last 1 week to take enormous efforts in organizing this particular webinar. I also thank all the panelists who have also taken a lot of efforts to really prepare relevant material to meet expectations of the participants. Myself and Dr. Giriraj, we have synthesized all the questions that we received from the registered participants. We collected questions from all those who have registered. We will try to address those questions during question and answer sessions. So most of the questions that you had in mind will be addressed during the course of this particular webinar. If you have any additional burning question, you may put it in the chat window, and time to time we will try to take that question as well. But mostly the questions will be taken care. So with these opening words, I would like to start this webinar by opening address from Ms. Simonetta Di Pippo, who is the Director of United Nations Office for Outer Space Affairs. She is personally not available because of clashing meeting schedule, but recently, just now, she has recorded her message and we have her opening address available. Patrick, over to you, please, to play the message.
I welcome you all to this webinar on space-based solutions for locust
early warning and preparedness. According to the UN Food and Agriculture Organization, the current locust swarms are the worst infestation to have occurred in 25 years in Ethiopia and Somalia, in 26 years in India, and in 70 years in Kenya. This crisis has affected 23 countries to date, from Pakistan to Tanzania. Most of the areas affected are in countries where a large part of the population is directly dependent on agricultural work and faces high food insecurity. Therefore, the impact of locusts risks not only precipitating poverty, but also lives are at risk. This is a single global outbreak, and if it reaches plague levels, it could cover 20% of the Earth's landmass. This is exacerbated by the COVID-19 pandemic, which has already disrupted global supply chains, including for agriculture and food transport. In order to face such combined challenges, we need to leverage the most advanced tools that humanity has available. And space applications offers, some hope. Space provides solutions that governments can rely on to respond to the current locust-induced issues, as well as to increase resilience to its future iterations. For example, satellites can provide continuous estimates of rain-producing clouds and ecological conditions, such as vegetation development, that are important factors for monitoring locust habitats and forecasting locust development. Essential climate variables monitored from space can be used to alert authorities about rising risk of locusts and to protect the crops. The Office for Outer Space Affairs and the International Water Management Institute are committed to spreading knowledge of the potential of space tools, particularly to protect the poorer and most vulnerable communities. This webinar aims to deepen awareness and understanding of the possibilities offered by space to counteract locust swarms, as well as foster exchanges of best practices and lessons learned in various countries that face the risk, from Africa to Asia. By offering such a platform open to all to participate and learn, we aim to promote the adoption of space tools in national policies and practices in increased resilience to locusts and other issues that can be counteracted from space. The Office for Outer Space Affairs stands ready to support all countries in this process. I want to thank all the participants gathered here for bringing their contribution and sharing their expertise, and also their questions for the benefit of all. We are proud to have with us today experts from a variety of organizations, including the World Bank, the World Food Programme, the Indian Space Research Organization, the Space and Upper Atmosphere Research Commission in Pakistan, as well as, of course, the Office for Outer Space Affairs and the International Water Management Institute. I wish you all a great success and a fruitful discussion. Thank you very much.
So that was message from the director of United Nations Office for Outer Space Affairs. It was very apt message that how the office would like to promote these space tools to help the policy formulation and fight with the locust outbreak. Next, we would like to invite Mr. Mark Smith, who is a Deputy Director General of International Water Management Institute. Mark, thank you so much for supporting this particular webinar as a co-organizer. So welcome, and over to you. Thank you.
Great, thank you so much. I want to start by saying how pleased we are at IWMI to be co-convening this webinar alongside the UN Spider program of the United Nations Office for Outer Space Affairs. And I want to thank you for your collaboration with us. I know that everyone who will be speaking in this webinar and who is attending this webinar, is in agreement that we are at present living in very interesting times. The World Economic Forum in its Global Risks Report for this year ranked the risks of infectious diseases, food crisis, and water crisis very high in terms of their potential impact. And those sat alongside in their risk rankings, they sat alongside risks of environmental disasters and, of course, risks related to climate change. Now, with the COVID pandemic, we're seeing all of these converge at this time. And in some locations, and I think we'll be looking at some of those locations indeed today, are having to deal with all of these crises at once. So it's an extremely serious situation. We all know that, we all agree with that. But as knowledge institutions and as research institutions, we have to respond. We have to respond with speed and we have to respond with urgency. And I think this webinar is one small step in helping us to do that. Here at IWMI, we have a strategy that we hope is helping us to do this. We are focused on using research for development to support the kinds of transformations that we need for sustainability and climate resilience and managing risks within those. We have strategic programs that look at water, food and ecosystems, water growth and inclusion, water, climate change and resilience. We also have a program on digital innovation. And within those and the linkages between them, a really important priority for us is risk management in agriculture and the application of the kinds of technologies that we'll be hearing about today, earth observation, data analytics, modeling tools, to help countries, to help communities build preparedness, respond to and manage the kinds of systemic risks that we are all learning so rapidly about in the world today, relating to food security, water security, climate change, and the interconnections among them, indeed. So the emerging locust swarms that we're witnessing are indeed a critical example of how these kinds of capabilities need to be deployed to aid response efforts. The proliferation of the desert locusts that we're witnessing across the Horn of Africa, the Arabian Peninsula, and now South Asia is linked to warming of the Indian Ocean and climate change. And then what we're seeing is a cascade across the system linkages onto farms as these swarms spread, which is raising really increasingly loud alarms ahead of the summer cropping season. And so it's really critical now that we can help policymakers, help local authorities, help farmers to make timely decisions about how to mobilize control operations. And it's fortunate in a way. We're talking a lot about crisis and very difficult situations, but we have new tools now compared to years ago. So it's fortunate that there are advances in technologies now available to us, high resolution climate forecast models, satellite data, drone technologies, artificial intelligence, and so on, that are making timely and hopefully better responses possible. So I'm looking forward in this webinar and to learning more about those technologies and tools and how we can deploy them. Very pleased that IWMI is involved, very pleased to see what looks to be close to probably 85 people joining this webinar. So I welcome you all and I wish everyone a very successful webinar and a very useful time with us. Thank you.
Thank you, Mark, for your wonderful opening address. And I would just like to mention that IWMI has been a great strength to United Nations Office for Outer Space Affairs, specifically for the UN Spider program. We have done a lot of work together, and this particular idea just came about a week back. It was not like a month ago or something. Just a week back, we thought, okay, there is a desert locust swarm is coming, and in South Asia, we should do something. And then we acted it on it, and it was really pleasure to work with your institution and Dr. Giriraj. And within 1 week, we can see that we have 9 excellent panelists, and we have all come together to have this webinar. and your work has always benefited farmers directly. So thank you so much for this. Uh, for the benefit of participants, I would like to mention that we have 9 panelists. So how we have structured now this discussion? First, we will have 4 presentations from 4 panelists, mainly from South Asia, and then we will have 15 minutes for question and answer. And as I mentioned that we have already captured your questions through your registration form. So most of the questions are already being taken care. So I would be posing these questions to specific speaker who has relevant expertise. And then after that, we have another 4 panelists who would be speaking more on technology and international cooperation. Of course, space remains the focus in each of the presentation. And towards then we again have question and answer session for those 4 speakers. And then at the end, we have Mr. Keith Chrisman from Food and Agriculture Organization, who also has enormous experience and global, probably expert in locust control. So he will provide us a way forward. So this is how the entire webinar is structured, and I'm sure everyone will get really benefited by this particular webinar. So first of all, I invite Mr. S.N. Sushil from Indian Council for Agriculture Research, and I would request him to provide some facts about the locust management and outbreak. So over to you, Mr. Sushil.
Thank you, Sirish. Good afternoon and good morning to all the viewers and participants. At the outset, I would like to thank the organizers for giving me this opportunity to put forth my views in this important webinar. So I shall be speaking mainly on the overall management of the desert locust and the biology. Next, please. Can you go to the next slide? Yeah, as we all know, that's an international transboundary insect pest. You can see here the dotted line. It stretches to the arid and semi-arid land, right from the Atlantic Ocean to the northwest India. So thus it is the dotted line. You can see this is a breeding area where they actually breed. This comes around the 30 countries and in 16 million square kilometer area. While this darker line is the invasion area where they can actually invade. So this comes around 60 countries where they can actually invade, and it's area-wise it's 30 million square kilometers. Maybe you can go to the next. Next slide, please. Yeah, these are the important species. In entire world, the 10 species of locusts is very important economically causing damage. While in India we have 4 species: desert locust, migratory locust, and then Bombay locust and tree locust. And this is how this life cycle goes. I just wanted to give you an idea that the eggs are being laid. Here you can see the picture. The adult locust, they are laying eggs. The solitary form and the gregarious form. The yellow one is the gregarious, the brown one is the solitary form. So they are laying eggs in the sandy sand where the proper moisture is there, and you can see the eggs, how beautifully they are laid. And these are the swarms. So normally a life cycle takes 2 to 6 months, and there are 2 to 5 generations in a year. We can go to the next, please. So the total egg stage, hopper stage, and adult stage. 3 stages are important. So the swarm which we are seeing now moving, that they are actually immature adults. So that's also called as fledglings. And their size is around 5 to 7 centimeter and weight is hardly 2 grams. So you can just imagine the size. And then the breeding season, they actually breed after the rains of winter breeding, and there is a spring breeding and summer breeding. The green color you can see here, this is all the summer breeding area, Indo-Pak border, and also some parts of this eastern part of Africa, and also the western part of Africa like Algeria, Mauritius, and this area. So this is how they breed and they move. So and these are the locust plagues. which came in India till 1962. We had a lot of locust plague. Plague means here that every consecutive years, like continuously 2, 3, 4 years or 6 years, continuous locust swarms we were getting earlier. Now at least we are not getting as frequent as it was in earlier days. But the last year was really worst for us when we got the 1500 locust swarm. You can see here the locust, the adults. Maybe next slide we can go. Next, please. Next, please. Can we go to the next slide? Patrick, can we go to? Can we go to the next slide? Can we go to the next slide? Yeah, please.
I think he's going to the next slide. We see that, but probably you are getting it late.
Okay. 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 Then if you are seeing the next slide, because it's not coming on my screen. So
I think it's okay. You can keep on
actually,
going. Yeah, we have 2 minutes more.
Yeah. Before that, I think warning organization, you can say, I was discussing, that is the organization which actually deals with the locust control in India. And that's actually their major job is to keep the constant visual through field surveys in approximately 2 lakh square kilometer area. And India is a member of FAO's Commission on Controlling Desert Locusts, that is SWAC, Southwest Asian Commission, and also India is a partner in Desert Locust Control Committee. And the Locust Surveillance Department, so LWO, they actually do the surveillance using the e-locust gadget, that's a real-time gadget. But the information which we provide based on the information, the FAO actually give us the prediction data, prediction model, a sort of forecast model. So based on that forecasting we are getting, and we are preparing ourselves. But then as far as the management is concerned, so total 10,000 acres per hectare is the economic threshold level. So we have recommended here in India 11 insecticides for use in the cropped area, while 4 pesticides in the scheduled desert area. And neem seed kernel extract was found very good, or other neem product also was very good in as a prophylactic measure, as a good repellent. And also Metarhizium anaceople, one variety acridum was also found good. It's a bioagent, which we recently have approved for use against the hoppers and locusts. And we are using all the the UAV, and also the different sprayers like Macro-Alva, Macroneers, and Alva Musk. Basically, still the reliance is mainly on the chemical insecticide. That's all from my side. Thank you very much for your patience here.
Thank you, Mr. Sushil. That was really good, because now we know our object and subject very well, what locust is, how it breeds, and what are the varieties, how it comes. So thank you for setting the tone for this particular webinar. You may switch off your camera and mute microphone. The next I would like to invite Dr. Giriraj Amarnath from International Water Management Institute. And I think he would give his presentation. That would be the first presentation that would directly talk about satellite data monitoring of the impact of locusts for preparedness and response planning. Over to you, Dr. Giriraj.
Thanks, Krish Ravan from UN Spider, and it's a great opportunity to partner with UN Spider to this important, relevant webinar. And I thank all the participants for being with us today. And I would also like to thank Mr. Sushil for giving the overview of the locust background and the management's efforts it is being done in India. I would touch upon more about what data and models are presently being used and what studies will be look forward in future as we step in further. The next slide. Yeah, this is a number that looks alarming in terms of the crisis. As we all know, several of the countries in East Africa, Asia, Middle East, and South Asia, which are prevailing with locust impact, which is also turns out to be the countries which are poor in health infrastructure or burdened by the coronavirus pandemic, and where it is more like a disease in which we are talking about a dual disasters happened between this crop which are already the farmers are affected in terms of the food security problems, as we have seen in several countries got into the lockdown. These numbers really highlight, for example, I just want to highlight, this is from FAO. In 1 square kilometer of swamp, it can eat the same food as 35,000 people in 1 day. So you can imagine if a farmer is producing a crop or in the early stage of the crop, if it consumes all these plants at a wrong time, the farmers will have crisis more in terms of the food security as well as the local economic crisis they will come across. I would just go to the next slide. Next slide, please. Yeah, this particular slide is more to talk about, this is more relevant when we are talking about early warning as such. Here we are looking at combination of long-term and seasonal forecast data that will give the government an advantage of what they could prepare when the locust will attack in those regions. And the idea is that we will use, for example, the IRI model can provide you 4 months in advance the probability of likely precipitation and temperature. And the Indian Meteorological Department provides a monthly short-term medium weather range forecast data, which is again available on a daily basis. So there are plenty of forecast models are available. It's important for the locust organization to, or the government authorities to use this to refine their preparations to deal with this crisis, where it is going to happen and when it is going to come. And the other interesting NOAA high split, it's more like a dispersion model, which is used for pollution monitoring, which is again for the recent years, FAO, NOAA and other countries are using this to look at what likely the wind dispersion will likely happen. So this is one of the way, you know, the kind of a swamp that has to go, it needs quite a good wind speed to travel. So it will be good for data like NOAA to use this for the state authorities or the countries to monitor what likely will happen. I would also touch upon MIRA too, which is again a plenty of data available. We could look at what is going to happen in terms of the changes in rainfall, temperature, or the wind direction, etc. You could easily get, they are freely and publicly available. Next slide, please. Yeah, this particular slide, what data, this is a very common question I have seen in most of the questions came from the registration. What data are really useful for monitoring? I must say that although it is not possible to detect locust population by satellite data, but remote sensing imagery are being used to help estimating the rainfall. If you know this is the epicenter of rainfall, if there is a variations in moisture or rainfall or other variables as I listed here, could able to tell us what areas are really are at risk and where likely the spread could happen. Obviously, it's not possible just from remote sensing. We might need to integrate field data as well as other telecommunication information to ensure a collated information that can be shared among the policymakers who would like to use. And it's a great portal FAO is doing with the ArcGIS system, where you could monitor the incidents or field reported, and they are readily available and freely for people to look after this information. My next slide and the last slide. Yeah, I think the key messages from our study is that we have started looking at this with data collection from the field and looking at what technologies and remote sensing data can be widely used for timely decision making process. Having looked at the states like Madhya Pradesh, we have seen satellite based rainfall and green cover have probably been the greatest impact of monitoring the locust population. And I must, as I said, that not technology alone will help us to prevent locust plague, but it is important to relate the field location and help sure that the locust prevention program uses this information for more preventive and early warning in order to reduce the frequency of the locust plague. With that, I stop here. Thank again. Over to you, Suresh.
Thank you so much, Giriraj, and keeping 5 minutes exact time. That's great. And also you, after knowing about Locust from Sushil, then you have given base for how satellite and other space technologies contribute. I think so we are going in the right direction. So after this, I would like to invite Dr. Rajkumar from Indian Space Research Organization, and he would share the experiences from India, space-based assessment of desert locust menace to Indian summer crops. So over to you, Dr. Rajkumar.
Good day to all of you. I will be just a minute.
Yeah, we are getting echo. Yeah.
Yeah. Now it's fine.
Yeah, it's okay. Good now. Yeah. Thank you.
So, yeah, good day to all of you. My presentation is basically on the studies done by us in Indian Space Organization for the ecological suitability of desert locust, damage to the various crops, and possibility of their migration and direction to other locations in the country. Yeah, that means within India, and space-based observations, ground truth data, as well as some of the atmospheric numerical model that we are running here, as well as the numerical model run by Ministry of Earth Science. So based on that, I will be making present. Next, please. Yeah, so if you see, first we try to study the various biometeorological parameters favorable for desert locust, such as high rainfall during last season in the Sahara as well as African region, as well as the optical soil moisture for their breeding, and finally the search for food, which is the availability of the green vegetation. So this slide basically it talks about all those things. If you see the left hand side, we try to analyze the data for many years, that is for the rainfall using our own INSET 3D satellite, which is giving every half an hourly rainfall data. So but here we are showing 2018 and 19 only, and here you see the 2019 case. Clearly the higher rainfall with the circle we have made it in comparison to 2018 in Sahara and North African side, the Horn side we see, which is one of the favorable parameter for the breeding. So that is one of the things we wanted to show. This is the one thing. Then if the bottom side, if you see the soil moisture, this is also one of the parameter where the breeding ground it is the important parameter. And here you see that in the Gujarat side, the north side, you see that there are two arrows are there. So there you see the high soil moisture, but not very high because you should not have the very high soil moisture, but optimal soil moisture for the breeding point of view in the desert location. So these are the locations where you see the dark green side. So those are the location in the arid zone in Rajasthan as well as central India. So these are one parameter. Then third parameter, as we told, is the search for food, which is one of the important parameter, that is the green vegetation, which can be clearly seen by the leaf area index, what we call it, from the optical sensors on the satellites. Here we have shown the MODIS image, 1 kilometer resolution for the same. In that, if you see the one the India image, and then because that is 1 kilometer, you cannot see clearly the where is the high LAI is there. But if you zoom portion, if you see in the Gujarat top side, which is the Banaskantha region, there you see the green part, that is a higher LAI, as well as in the bottom of the zoom portion, that is in the near the Jaipur. So where we have seen a lot of locust swarm was there by observations itself. So, and the bottom side, if you see the right hand side, this is the actually the model output during that time, where we have shown that clearly you see the wind pattern. So because of that, where it's supposed to go, a strong westerly wind, if you could clearly see from in the northwest to central India. At that time, actually, Amphan cyclone was there, and so because of that, it was moving that. And this we have taken from our own site, which is mosdec.gov.in, our ISRO site. Yeah, next please. Next slide. Somebody's mic is on. Yeah, yeah. Here, if you see that, after that, what we wanted to do it, we analyze all these data, and using that mainly our we have our website is called vedas.sec.gov.in, in which we contain the data as well as very good analysis tools for many applications, including vegetation or agriculture is one of the major things. And also we use the Google Earth Engine for Sentinel data analysis. If you see that, it can be clearly seen by NDVI pattern. This is on the left-hand side. The NDI pattern should be actually, if you see from the Rabi crops, if you see, it should be, generally it is higher in the month of February, March, April, and then afterwards it start decreasing because of the harvest season. And then after harvest, it should again start because of the summer crops. So summer crops, normally what should happen, it should go on increasing. But because of the, either because of the for the harvests may be there, or maybe because of some other region like Locust. If you see the dash curve, suddenly you see the permanent less LDVI will be there, and that what we have taken in analysis, we have taken is 0.2 is the threshold, and it goes 0.2, and suddenly, and in bright in April or suppose it is higher. So that type of analysis we have taken and seen that if it is like that, that means it will be because of the locust attack. Otherwise, if it is supposed to cut is there, powder cut is there, or harvest is there, because that after the sudden drop, again it will increase. But in locust case, it will not be increasing. So that analysis we have.
Dr. Rajkumar, 1 minute you have, please.
Yeah, sure. Right hand, and then bottom you see that there is the image from the resource set, our own resource set AWS data, and on the right hand side we see the Sentinel data. So from this also we can clearly see the area where the NDVI anomaly we have seen. Next, just click one. Yeah, so here we show the actual graph, what we analysis we have done in 2018, 19, 20. You clearly see the sudden drop. You see the 2020, whereas 2018 and 90, neither in the AWS data nor in the case of the Sentinel data, you are not showing this. But in the 2020, you are seeing the second week of second fortnight of the May, clear dip is there. So it is clearly by this analysis, as well as based on the top some of the actual observations where the swarm has been seen. So by the LWO, Locust Warning Organization. So based on these, we can clearly say these are the area where the locust is damage is there. Yeah, next please. And when we see that damage is, when we see the damage, then we have to where it will go, where it will migrate. So that is a bigger question. For that, there are two important points are there. Either you should take a leap area index, because where is the food is there for everybody, not only for the locust, for us also. Everybody want to see the food. So for food is there, they want to go where the more food is there, and then proper favorable conditions like wind condition is there. So that heuristic prediction we try to do based on the two models. One is the WRF model, 5 kilometer model, what we are running with the data assimilation, satellite data assimilation. That is a 3-day forecast, and then on the based on the model, which gives the longer range predictions by Ministry of Earth Science. And we can clearly see there's some of the location where it will be going. And then if you see the earlier, there were two branches there. It was supposed to go the north as well as the east side also. But afterwards, if you see in the longer predictions, it is clearly seen. It may not be going there. Mostly it will after the west east switch, it will possibly move back towards the Thar Desert. It looks like it will go to the Thar Desert in Rajasthan because of the south westerly wind. And those happened also because of another cyclone came in the last week in Nisarg in the Arabian Sea, and also because of easterly wind from Bay of Bengal to the southwest monsoon. So our till now analysis shows that it will be towards that only, and we have seen also the other predictions also maybe after 11 June. Just now I was seeing. So even up to 20th also, it is similar to it is going to the northwest direction. That it looks like it will be towards that. Thank you. I would like to thank UNOOSA for arranging this discussion, as well as extremely thankful to my colleagues who worked on this. Thank you.
Thank you, Dr. Rajkumar. So that really demonstrates your efforts of making full, exploitation of technology to support this particular work of desert locust control. Now let's go to Pakistan. How the Space and Upper Atmosphere Research Commission, SUPARCO, which is a space agency of Pakistan, how they are using desert locust control, geospatial monitoring system for desert locust control. So I invite Mr. Ibrar ul Hassan Akhtar to share his experiences from Pakistan. Over to you, Mr. Ibrar. It looks like you are mute, Ibrar. Mr. Ibrar, are you muted? Can you please check? Mr. Ibrar? Okay, so what we can do is maybe when Ibrar is ready, he can put me message in the chat. Then we can just move forward until the time he fixes his microphone or something. So yeah, so what I can do is I can take question answer session at this stage, and if Ibrar comes back, we will again take his presentation. So right now we had 3 presentations about the facts of locust by Dr. Sushil, and then Giriraj Amarnath talked about how regionally they are using satellite images to understand preparedness, and then Dr. Rajkumar from ISRO. So when we looked at the lots of questions that we had received from participants, there were definitely a lot of curiosity, and I would like to ask first Sushil, just follow-up question on top of your presentation. What prompts locusts to swarm, and why are they not a regular pace? Like in India and Pakistan, probably after 26 years, in Kenya, maybe after 70 years. So what is the things behind this? Can you please just clarify this particular point?
Yeah,
Sushil.
thank you, sir. Thank you for your question. In fact, they are normally they are in solitary form. So long there is no crowding, there is no dearth of food. Normally, as I was showing my slides, so initially hoppers, they are small, like they mold for 5 times, then they turn into the immature stages, that is also called fledglings. So once they are at the 5th stage of their hopper stage, that's the early stage before immature stage. So if there is a crowding, so then there is this you can see here this their legs, they get touching, there is rubbing or touching with the other individual, and also once they see that there is a crowding, then their brain actually secretes a hormone that's called serotonin. And once there is a secretion of serotonin, they convert into the gregarious form. So the gregarious form means then there will be band sort of thing. Their movement is in the bands form, and then they convert into the swarm form. So then they fly long and they go quite longer distances. But then if there is a food availability is there and there is a less number of individuals in an area, breeding area, then they will remain in the solitary form. Then they will never convert into the swarming form. That's the reason, that's a physiological reason behind the swarming. The second question which is asked is why it was not coming. Actually, the last year, if you see the spring season rain, it was perfectly very good rains we received, especially the desert area. And even previous, the winter rain was also equally good. And even 2018, there was a very good rains. So from there only it is started. The story started from 2018 spring season rains and also summer rains. So after that, there was a good breeding. So the next generation, again, there was a winter good rains. In 2019, we had a very good spring rains. So that's continuously they were breeding and they were getting good rains because for egg laying they want a good moisture and the sandy soil. So they got very good moisture and also in the desert area, and that's why they bred in a larger number, and that's why the swarms are now coming this year.
Good. Thank you, Mr. Sushil, for this particular thing. We are getting some more questions, but I will come back to it later. Let me go to Giriraj Amarnath. You can mute Mr. Sushil now. Giriraj Amarnath, thank you for your presentation and setting the tone with how space technology helps. The question that coming from participant is that how seasonal and short-term weather forecast data are useful in locust early warning, especially in a prevailing situation of locust plague in 2020. If you can explain in 1 minute quickly. Thank you.
Thanks, Suresh. Actually, to some part, I have briefly mentioned in my presentation. As we see, there is an increasing use of seasonal and forecast with more reliable and high resolution informations are available. It is, for example, the IRI or ECMF or NOVA are equally producing a high quality seasonal forecast information, which can really help the locus authorities as well as the national authorities to know how to deal with this crisis specifically in visible areas, or you have two different zones, invisible and visible areas. So if you know that these are the containment zone and you know there is abnormal moisture is increasing, that is determined by 3 months or the short-term forecast, you have certain plan in place to deal with this crisis. That is one part. And increasingly, you can see there are a lot of high resolution village level forecast data are also available. It depends on the level of accuracy in a specific region, and you could pretty much get 6 hours short-term forecast to 10 days in advance, medium weather range forecast on all sort of climate essential variables, whether it is temperature, rainfall, wind speed. I think we are in a very good framework in atmospheric model, and that's a big development from space agencies. And if that is there, and what we also know very clear from the forecast, you have a second scenario to understand where the vegetation and the rainfall is happening. You cannot really do this in a very limited time. You could bring in machine learning tools, whether it is a random forest or regression model, and then try to come up with the areas where likely this models can provide a predictions. So I would say that there is an interesting development happening on this field. And I think the more we have presence and absence of locust spots are available, the field data are available, you could pretty much provide a reliable models there. Yeah, over to you.
Thank you, Giriraj, for clarifying this further question. Now I switch to Dr. Rajkumar, and I also see in chat box you have a lot of questions. The question that I recorded from registration is that is it possible for satellite sensor to detect locust at early stage so that early warning can be provided? But also I see some burning questions on the chat. It just asks the drop in NDVI, is it because of just locust, or it can be also because of drought? So how do you assess the reliability? So if you can give comprehensive response, but within 1 minute or so. Thank you so much, Dr. Rajkumar.
Yeah, sure. I wanted to say what you are talking about, mainly the locust monitoring and tracking what type of satellite data. Satellite data, as I already shown, what we have used is Sentinel data 10 meter as well as AWIMS data 56 meter. These are okay, but not very sufficient. If you really want early tracking, then you should have a very high resolution. If you have a sub-meter resolution data for the certain location where breeding is taking place, if you can have a monitoring of those locations with a high resolution, then I think that will be very, very useful. And maybe like our own GI set when it is coming with the geostationary satellite with a high resolution, because regular monitoring will be there, or maybe low Earth orbit, any other satellite with the sub-meter resolutions. So those things will be helpful in this case. And another question you were asked something.
There was curiosity by someone that the drop in NDVI is necessarily by a locust or drought also.
Yeah, that I showed clearly in our one slide also. If it is because of harvest, it will come up again. But if it only because of locust, it will permanent damage will be there, and NDVI will not be come up again or increase. So that is one of the determination or analysis we did. But certainly we like to have some data of the ground truth also. That is also required, because space-based data always has to be supported by the ground truth. but space-based clearly it can be seen. If you have a high resolution, then we can pinpoint also where their location. Even by the radar also, people have seen ground-based radars swarm these swarms. Thank you.
Right, thank you, Rajkumar. There are many questions, but maybe if time permits, we'll come back to those questions again. So I guess Ibrar is back. Ibrar, are you there? Mr. Ibrar?
Yes. Can you?
Okay, are you ready for presentation?
Yes, I am.
Okay, Patrick, please display his presentation, and Ibrar, you have got 5 minutes, so please try to summarize in 5 minutes. We lost some time already. Thank you.
So should I start?
Please go ahead.
Good morning, good noon, good afternoon, good evening to all panelists and the participants of the webinar. First, I would like to appreciate the effort done by UNOOSA and International Water Management Institute in organizing this webinar. So briefly, let me introduce that my name is Ibrahim Hassan Akhtar, and I'm working as a general manager in one of the National Agriculture Information Center in SPARCO. So I have expertise in entomology, in remote sensing, as well as almost completed my PhD in climate sciences. Next slide. Before going into my presentation, I would like to give the background that what we have faced in Pakistan during last 40 years, around 40 years, and about little briefly about the current scenario of a locust attack within Pakistan. So on the left side, I have tabulated the data from the Desert Local Information System FAO, that which years these swarms and how much area has been affected by locust. So it clearly shows that prior to this outbreak, 1993 is the most affected years for agriculture by the desert locust. And on the right side, I have used that based on event analysis. I have created the hotspot. What are the areas where the desert locust swarm has affected within the Pakistan? So it clearly shows that the Cholistan and Sindh Thar areas, as well as some areas in Balochistan, has been affected by desert locust. And I am working on this report. Hopefully, I will complete within next 2 to 3 weeks, in which I have given background as well as this how space technology can help in developing a geospatial system to assist the national locust control centers as well. So next slide. So this is what we have developed, a monitoring system based on satellite technology, remote sensing, GIS, GPS, and other sort of technologies to assist the government of Pakistan and the agencies which are actually trying to control and manage the desert locust within Pakistan, especially the provincial as a national disaster management authorities and Ministry of Food Security. So we have developed a system which has 3 components. One is desert locust habitat suitability mapping, which actually takes into account all those weather parameter, atmospheric, the past, the present, and the forecast, to check where it can be present and where is the highest probability of its presence, and where it has a least probability, to assist the ground survey teams where they should search for the desert locust and possible breeding areas and the possible areas for the swarm to come and affect the agriculture crop. Second part is based on high resolution imageries. We can somehow give a reliable estimate to the donor agencies as well as to the department like disaster management related to damage assessment to the crops, and we have given estimates to the relevant department. And the third is assemble model, in which we use especially the weather forecast as well as integrating the trajectory models and the growth development models to forecast for 3 to 4 weeks from point to where the locust swarm will move. Next slide. So I will only explain the first component, which is how habitat suitability mapping was carried out. So I separate two variables into, one is environmental variable, which is related to which support the epidemic chances. Epidemic locust can breed well, and it can convert into gregarious behavior, and it can migrate to agriculture areas. So these are briefly listed down, that land surface temperature, precipitation, soil moisture, and normalized different water index, land to land cover, air temperature, wind, green indices, which we call vegetation, NDVI, evapotranspiration, topography, especially the elevations, which actually determine their track where they will move. The soil type, these are the environmental variables. Second is a key locus parameter, which actually relevant to the hatching, the growing cycle of the insect. So here we have used we have identified the key variables based on the Markov chain process, probability transition, that if it happened in past, based on precipitation and anomalies and soil moisture, is it when it will happen in near future, 1 or 2 days. And neural network we use to identify the key areas where it has a highest probability. So I separated into 5 categories based on decision tree algorithm. So to help where the surveillance should be, have the survey team go on a priority instead of moving throughout the desert areas looking for the breeding and so on. So this is key variables and model. Next slide. So that was a model, how it was, how the different variables were integrated into a product which can be used by the authority.
Ibrar, we lost you. Are you there? Ibrar? Okay, there seemed to be some problem. Maybe we can move to the next, and we can then come back with some question to Ibrar little later. So Patrick, shall we can go to the next presenter, Mr. Wenqiang from China.
Yeah, video you have.
Okay, so we have completed first 4 presentations. There was some technical trouble for Ibrar. If time permits, we can just come back to him with the question. Most of the slides and presentation he has done already, and question and answer session has already been done. So we have next 4 presenters, and I would like to invite Mr. Wenqiang Huang from Chinese Academy of Sciences to talk about role of his organization in locust monitoring, right from Africa to Pakistan, how he's supporting this. Over to you, Dr. Wenqiang.
Yep. Okay. I'm Wenqiang Huang from Chinese Academy of Science. And now, we have done some research and try to use some aerospace technologies to support the locust and modeling and assessment and using an aerospace technology. And we have done in different countries. And could you turn to next presentation? And could you move to next one? Yep, I think that my colleague and Dr. Yin Zhong and we are giving more description about what we have done and different countries. How about is the locust maybe is the migration path and something. Okay.
Okay. Hello, everyone. I will give a brief introduction of our work on the desert locust monitoring and also loss assessment. So what we did is we use multi-source observation data, meteorological data, and field data. And also we have our models and algorithms, including the data mining algorithm and also the pest dispersion algorithm. So what we did is about the migration pairs monitoring and the prediction in the whole Africa and Asia. And also we did the migration pairs monitoring in the main countries like the, sorry, next page, please. Okay, so in Pakistan, Serbia, Somalia, and Kenya, and Yemen, we did the very detailed migration pairs in these countries. I know that the locust is fly from Yemen to Ethiopia and Somalia, and the Kenya is the most serious damaged country. And also in the Pakistan, the locust is mainly in the border, in the Indo and the Pakistan border around the three desert locations. Okay, so please next. Okay, in Pakistan, we did the monitoring from the 2019 to now, till the end of April, and we found that the vegetation areas were harmed very serious, especially to the cropland, and also some grassland was damaged too. Also, we choose the meter resolution satellite data like the planet and the world view to pay attention on some very serious damaged areas in the middle and also in the north part about in the Punjab province. Next, please. Okay, in Ethiopia, we also did the monitoring of the locust from the 2019 to the May 2020. We found that the mainly damaged vegetation type is the shrub. Then is the grassland, also some cropland. Also, in the middle of this country, we found that there was a very serious damage in the central Afar, western and southern Somaliland. Please next. So in Somalia, we also did the monitoring in the 2020. We found that there was 392.1 thousand hectares of vegetation are damaged in this area. Also, cropland is not so many, but the grassland and the shrub is the mainly damaged vegetation type. We found that it was mainly distributed in the south part and also in the central part. Next, please. Okay, so in Kenya has this very serious desert locust around 70 years. So we found that the vegetation was harmed around 3,300,000 hectares of the vegetation, mainly of them as grassland and shrub. Also for the cropland, there was a very serious damage in this country, and it was mainly distributed in the Rift Valley province and the East province. And also we can see that in the Rift part, there was a very serious damage here for the cropland. Okay, next. Next page, please. So in Yemen, we know that in Yemen, the vegetation was distributed in the west part and the south part. So the damaged areas is also around here. The damaged area is around 1,500,000 hectares here. The mainly damaged vegetation type is cropland. And also we found that from April to May, there also increased of the damaged areas. Next, please. So we, from the February of 2020 to now, we have released 8 reports about the desert locust monitoring and loss assessment. So all of our reports and the data was open to public. So you guys can find the data and also what we have did, also about a very brief introduction about our method and the data here. So that's all. Thank you.
So thank you so much, Professor Wenqiang and colleague, for presenting all the efforts from Africa to up to Pakistan, how we are helping. I will come back to each question after three more presentation. There is one question that we already have for you. Meanwhile, other panelists, please look at the questions asked specifically to you, and you may respond those questions in chat. Some of you have already done it. That will save a lot of time. So thank you so much, Professor. You may switch off the camera now. I would like to switch on to now Mr. Swapnil Chowdhury from Pathway Technologies in Nepal. As we know that Nepal is not suffering from locust attack, but
Hello.
Swapnil, you can go ahead.
All right. Yeah. Thank you so much, Shirish, and all the organizers, as well as hello to all the friends who are present here from across the world. At Pathway Technology, what we do is like we customize the ICT-based solutions in the form of agriculture advisory for farmers. We have roughly around 200,000 farmers in our database, to which we provide information from right at the beginning of sowing all the way up to pre-harvesting and the post-harvesting phases of the plant and managing the areas. But now here we would be focusing on disease and pest attack and how the ICT could potentially help into this. Next, please. Yeah, while we talk about these space-based applications, one of the primary sort of stakeholder or the audience of our research is often the government authorities as well as the agencies which are going to look at the mitigation as well as the recovery phase. But very often we also need to consider how all this space technology and the information that we are generating could be effectively delivered to the farmers. These farmers, in our experience, what do they always require is reliable, trustworthy, and effective information that is a responsive, because it is time-sensitive issues when outbreak like this happens, which is customized, as you would know that the farmer in Africa would have a very different challenges as compared to the farmer in Pakistan or in India or other South Asian countries. The information that we deliver has to be simple, needs to be easy to understand. And the important part is that if you look at the communication pathways that the farmers often rely on, it is a social communication. So once they have understood this information, they need to be able to communicate it forward to their fellow colleagues or the other farmers. As I mentioned here, the farmers, I would also like to highlight that the livestock herders are also equally very prone to this locust attack in these unforeseeable times. Of course, the information needs to be actionable, delivered in a very simplified way. It needs to be time responsive. Time is a most essential and like a very crucial element. And they need to be accessible. As my colleagues from China, as well as from Pakistan and from India would recognize that access to the information is one of the most essential elements. And not everybody has access to the digital technologies. So what could be the alternative pathways of communicating with them? Could it be radio? Could it be SMS? Could it be print media? Could it be social media? Or could it be mouth-to-mouth publicity? As we move forward, let's look into how the information technology and communication would actually converge with all this data and sciences to deliver these technological solutions to the farmers. Next slide, please. As you would look, very often, this locust outbreak has a parallel to any other disaster that we often look at. And the disaster preparedness and responses always fall into these core categories: plan and prepare, mitigate, response, and recovery. In each of these phases, there are different actors who play a crucial role. When it comes to plan and prepare, all the geospatial data that has been made showcased by my esteemed colleague in the prior presentations, those are synthesized and deliver. And the most important part that this remote sensing and GIS solutions provides us is the time. If at all, now that there are already postulates that there will be a second wave of locust outbreak that might hit the South Asian continent somewhere around July and August, or even early as this time. So how do we prepare our farmers that this eventuality which is going to strike to their farm, what can we do to prepare them? There, of course, then comes the response mechanism, where once the disaster hits, once the locust has entered into the territories in your target population, what kind of effective evidence-based solutions can we actually tell to the farmers? As Dr. Sushil was mentioning, that the hoppers, when they are just at the hopping stage, that is the best time to actually eradicate them instead of waiting them to grow into a full adult, where then they become a breeding population and then the population exodus starts to happen. So if you could actually convince and give evidence-based, very practical guidelines to farmers, they become as good as our own soldiers who can work on the ground and then help us to mitigate the damage that this locust outbreak can cause. And of course, you then need to have a mitigation and action plan. And then once the locust recovery has damaged the crops, how exactly do we recover the loss that the farmers have assessed? In our experience, what we have done in Nepal is that each of the farmer is mapped along with their total acreage and also what kind of crop they are growing. Once you know the crop that got damaged, because you have the entire profile of the farmers, you would be able to understand what kind of compensatory mechanism needs to be rolled out for each of these farmers. And of course, many of my colleagues have worked in flood inundation and other such disaster, where space-based application could be utilized to really assess the total number of damaged areas and then really see each of the farmers which has really looked at or requested for the compensation, whether they deserve that compensation. And also just want to highlight, and in the response mechanism, there are also quite a use of robotic sciences as well as the drone technology that Dr. Sushil was also mentioning. They provide a very, very effective and a very surgical precision when we are responding to a locust outbreak, because the locust does not directly affect at the equidistance and equal proportionate to all the crops. There are some places where the farmers have grown agroforestry crops versus some farmers which are growing just the cash crop or the other places. Next, please. And just to give you a brief illustration as to how our platform works in the two regimes. One is like a mobile version, which is the handheld devices that are used by the farmers. You need at least one family member who have a little knowledge about how to use the mobile app in one family that can actually then translate it to the multiple farmers. They use this technology to both to report the incidents, but also at the same time communicate both ways, both to the scientists, to the government, and receive and give the feedback. And at the same time, you have a digital platform or dashboard, which many of my colleagues and many of the participants would be familiar, which is a real-time platform where each of the farmer which report the incidences, that coupled with the multiple layers that comes from the spatial databases are overlaid, and then really multiple analyses are run, both in terms of the plan preparation and also how to react should such kind of disaster comes into the next phase. These are some of the the idea. And as the communication angle I was mentioning before, there are multiple ways of communicating. So it's not only the mobile phone, but also other channels through which you need to deliver these messages to the farmers. These were my 2 cents in terms of how Pathway Technology looks at this disaster and would like to contribute in coming time. Thank you so much.
Thank you, Swapnil, for bringing ICT dimension to this particular webinar. It is very important to reach to the farmers, and that is possible through these mobile-based solutions, and farmers can then get involved in the entire process of controlling locust. So thank you for this presentation. Next we have Eric Fernandez from World Bank's Agriculture Observatory, and he's in Washington DC. Probably it's 4 o'clock there. So thank you for waking up so early to be with us. So please mention what World Bank is doing in order to control desert locust and your role. So over to Dr. Eric, please.
Thank you very much. Thank you for this kind invitation to participate in this very interesting webinar. It's a pleasure really to hear colleagues from the UN, from India, Pakistan, China, and Nepal, and all of you have provided some very, very insightful knowledge. I think this is really encouraging coming from our stakeholders across the world. So it's let me give you a brief overview of how we are trying to use your knowledge, expertise, and insight to help our client countries where the World Bank operates. So my name is Eric Fernandez. I'm a lead agriculture specialist. I've been in the World Bank now for about 20 years. And before that was in academia, where I used remote sensing in agriculture and at various stages of operations and preparation. Next slide, please. As has been highlighted, we are now in a crisis within a crisis. We are all facing some quite difficult situations, and it's amazing to see how adaptable we are across the world and in responding to this, some more rapidly, some less so, but it's important to learn from our experiences. And I think this webinar is a nice example of how we bring together collective insights, we learn from one another, and how we apply that for the collective good. So particularly in this session, I'm going to focus on how the bank is responding to the various issues that you have highlighted in the previous presentations. All of you have highlighted the crisis, have highlighted the cost. It runs into billions of dollars globally that we have been able to evaluate. What is being done in terms of actions and how we in the bank see as an important way or pathways to help you both in the UN as well as in the countries to more effectively respond. Next slide, please. So very quickly, the first thing we did was to mobilize what we call the Contingency Emergency Response Component, a CERC, within the existing portfolio of lending that the bank has, and focused in this case in two countries. In Djibouti, on the left, you see just over $500,000 US, and in Kenya, in the context of the Kenya National Climate Smart Agriculture Project, that's a 13.7 million program or component. And basically it covers a variety of response actions. On the left in Djibouti, you see purchasing of equipment, logistic, pesticides, whether it's synthetic or biopesticides, initiating preliminary capacity building to start to build this early warning system, and then assisting affected farmers and agropastoral households in restoring livelihoods. A very important component of helping colleagues and farmers and other stakeholders of the value chain at the ground level is restoring their livelihoods, because once they lose assets, it becomes very difficult for them to continue their activities. So that's an important component of a lot of what we're doing. And again, as you see on the right in Kenya, responses include base stations deploying surveillance aircraft to coordinate surveillance efforts across affected countries. That's important because all of you have highlighted that this is both a national, subnational, as well as a transboundary program. And in our portfolio, we see it covering 3 regions: Africa, the Middle East, North Africa, and South Asia. Next slide, please. So another important development at the World Bank is that we rapidly put together what we call this multi-phase programmatic approach, the MPA, and we have put together with the approval of the World Bank's board a $500 million package to look at 3 major components within an emergency locust response. So monitor and control, continuous surveillance, control measures, risk reduction and management are the subcomponents of that. The second is protect and restore, and that was what I was highlighting earlier: safeguarding food security and protecting human capital, restoring and rehabilitating livelihoods, and assessing the impacts, all of these happening simultaneously and in a phased way so that they inform each of these components and subcomponents. And then the third one, which is just as important, is coordinate and prepare, strengthening early warning systems, improving institutional coordination at subnational, national, and regional levels, and supporting the development of critical supply chains. Even getting supplies to local actors becomes quite critical. And this 500 million MPA program in phase 1 is targeting these 4 countries you see at the bottom. Okay, and the intention is that we will phase this up as needed. In the bottom right there you have the task leader's name, Melissa Williams, and her email address. So if you need specific information, this is how you can get it by contacting my colleague Melissa Williams. And she's overseeing the MPA program for Djibouti, Ethiopia, Kenya, and Uganda. Next slide, please. Okay, so one of the things I do at the World Bank is to look at the to coordinate the Ag Observatory, where we do use a remote sensing component. We use the Global Precipitation Measurement constellation of satellites, together with ground weather stations and a range of big data and artificial intelligence algorithms and approaches to generate a worldwide grid of 9 by 9 kilometers of daily weather. And this weather we have both daily and as well as historical going back to 2006. This allows us to do a very high resolution hyperlocal monitoring of weather and how that might impact a range of indicators that are useful in tracking locusts. So I'll stop there because it's getting on for just over 5 minutes. But this is in essence the variety of components that the World Bank is looking at, from soil to satellite, empowering all the actors in the value chain to take this tremendous amount of knowledge that all of you have highlighted and apply it in an early warning, early action, monitoring, reporting, verification, and further action. So thank you very much, and look forward to discussing any of your questions. Thank you.
Thank you, Eric. This is very insightful how World Bank is doing its best, not only supporting financial instrument, but also bringing technical products from agricultural laboratories. So definitely we have some question for you. We'll come back to that. So thank you, sir. So among the panelists planned presentation, we have now World Food Program colleagues, Mr. Iftikhar Abbas and Sarah Bashir. They will be talking more on the vulnerability assessment and mapping. So over to you for 5 minutes, colleagues from World Food Program from Pakistan.
Hello everyone, and thank you so much, Luis, for organizing such an interesting webinar. I am Sarah Bashir, and along with me is my colleague Mr. Iftikhar Abbas, and we are working at the World Food Program Pakistan. At World Food Program, we are closely looking at the food security situation in the country, and with the recent outbreak of locust, we are very much concerned about the food security prevailing in the country. As some studies have also mentioned that locust swarm can 1 kilometer square swarm can eat the same food as 35,000 people in a day, and it's same as the same food as 84 million people in a day. So it's very alarming, and it has raised quite a concern at WFP to monitor and assess the locust losses in agriculture and vegetation. Next, please. Just to give you an overview, already my fellow presenters have mentioned the potential of remote sensing and monitoring the locust outbreak. Already have been mentioned that sensors like MODIS, Sentinel, and SPOT can be used to collect the data, ground data. Also, the precipitation and temperature data, which can be used to from TERPs, can be used to monitor the data, and also moving towards the new technology like drone. It is quite helpful in surveillance as well as in responding pest management. Then the use of GIS is quite inevitable because of food security is a complex phenomena which includes multiple indicators, and for Locust analysis we analyze food security indicators like food availability, access, along with the Locust indicators which include soil, temperature, slope, and NDVI, etc. Also, this GIS is used for identification of a vulnerable population which is affected, and we can see the trends and forecast which areas can be evaded by the Locust. Also, GIS is very much helpful in creating the story maps, which includes both the pictorial representation maps and textual information, in also the videos, which can help in giving an interactive information of the Locust outbreak. Along with this primary data sets, the secondary data set and ground truthing is very much important, in which the soil texture and soil moisture is important for and the in analyzing the habitat type of Locust. And to further validate this data collected through remote sensing, ground truthing and field data collection is really important. Next slide. For this, the field data collection, I would like Mr. Iftikhar Abbas to continue with the presentation. Thank you.
Thank you, Sarah, and hello to all participants. Colleagues, as the topic of this webinar is actually the application of space technology on the Locust assessments and observation. In spite of this present state of the art technologies, we never deny the importance of the conventional data collection methods and tools like field data collection and other conventional tools. So in parallel to the space technology that we are here in World Food Program, we are testing and implementing, we have another platform that we call it as the MWAM, mobile vulnerability analysis and mapping. And through this platform, actually we collected that data in the field through a number of tools. For example, by applying the a tool for key informant interview through focus group discussions at the community level, as well as household questionnaires. So in addition to that, as you all know, that World Food Program is an emergency-based organization, and usually during emergency, the access to the communities or access to the field sometimes is very difficult. And for that, we have some alternate solutions and platform. For example, even during the current situation of COVID-19, where there is it's not possible to have face-to-face interaction with the community and with the key informant interview to have the field information related to this Locust prevalence and Locust invasion in the agriculture field. So for that, actually, World Food Program has an established platform of MWAM, and actually this platform was piloted in 2013, and this approach is now being used in over 40 countries, and WFP has actually successfully tested and implemented this MWAM tool, and we have a very good experience of using this tool and collecting the data through this tool, and then analyzing the data and then designing our programs to fulfill the food needs of the community. In addition to that, we have a very good platform for web surveys, and actually this platform was piloted in 2018, and now actually we have replicated and tested this tool in around 10 countries across the globe. So I mean to say that
Iftikhar, one more minute, please.
Yes, I know. And thank you. And I mean to say that through this tool, actually, in addition to those space technologies, these tools offer additional valuable information to valuable support and information to have assessment on the Locust damages. Next, please. Now through this slide, actually, I want to update with all the participants that what is the situation in Pakistan on the locust invasion and how what food program in joint with the food and agriculture organization and with other key government department, how are we responding? Actually, so far in Pakistan, around 38% of the country is actually the breeding ground for this desert locust, and here around 38 districts across the country are affected by this desert locust. And initial estimates indicate that around 115,000 hectares of agriculture land is been affected by this locust, and over 17 million hectares has been surveyed so far, whereas around 1 million hectare has been treated through a different treatment like spraying. And WFP and World Food Program are closely interacting and closely coordinating with the national government here, including all the partners. And so far we have we are very closely engaged with the Ministry of Food, National Food Security and Research, as well as the Department of Plant Protection, and we have already provided the e-locust tool for desert locust survey and control reporting. Also, we are in the process to procure the equipment like survey devices, vehicle mounted ultra low volume sprayer, as well as vehicle and pesticides. In addition to that, we are also planning actually to have a detailed damage and need assessment in collaboration with the government and partner, and we have already completed all the preliminary work, and we are going to now roll out this assessment in next week. And we are also supporting to the national government on mobilizing the financial resources and ultimately based on the finding from our damage and need assessment, will be designing our programs to fulfill the food needs and other requirement of the communities. So this is all over from my end. Over.
Thank you. Thank you, Iftikhar and Sarah, for wonderful presentation. And message is very well taken that it's not just remote sensing data or satellite images, but we also need to very good ground survey data, and you have established that mechanism. There was already question for you, but you already answered that. Someone there was a question during registration that they were asking how you are using this data for damage assessment, how you work with the government. So you already addressed that. So I may not come back to you immediately, but I would like to ask. Okay, there is a question answer session, but before that, I would like to take permission from Keith. Our FAO colleague, Keith Chrisman, can you wait for 5 minutes for like 1 minute for question answer by panelist, and you can come back, or you would like to give your comments now? Because I know that we had delayed little bit. So what's your opinion? I would follow that.
Okay. I can wait. Go ahead.
Okay, great. Then that will be good. Then you can take account of everyone who's spoken and then give your views. Thank you for waiting. So I would like to ask question to our colleagues from China. Based on your presentation and what I can see, okay, let me go to that question. Yeah, so you have all the products generated right from various countries in Africa, all these Ethiopia, Kenya, and all until Pakistan, and how these products are actually contributing to the locust early warning. Are they getting available to some authorities in that country? And also, someone was mentioning on the chat, the estimates that you have done, damage assessment, are they really from, how do you assess the accuracy, whether they are by drought or it's also only by the locust? So these are some of the questions. You can take 1 minute to answer, not more than 1 minute. Thank you.
Okay, thank you. Also, as you mentioned, that we have used them and different kind of data. And for example, first is and we have used some mass and source data, for example, and we have used different resolution satellite data such as the MODIS and Landsat and the Sentinel, and for the from the year 2000 and to now, and for the MODIS and Landsat and Sentinel from the year 2050 to now. And we also use some meter satellite and resolution data, and such as the Chinese and GF series, also planet or the wood view, and in some main and diameter areas. And we also use some greenish rainfall and some other data from the FLO, also from some cabin and from some Pakistan and institutions. And another one is just as you mentioned about the models. And first we have conducted about the habitat analysis based on different resource and data, and also we have used some maybe to find how about the hotspots such as the cave breeding areas and the main damaging areas. Then we have used the vegetation growth conditions, and we have extracted from some long-term and series of satellite data for about more than 20 years to analysis how about the damage and about the nose, about the yield nose. In our periods, maybe for the early warming, and we think that maybe we should try to identify about the hotspots and the better or really maybe about the pasting and prevention, in which and we have used some different kind of data. We use the data mining methods to for about more about the field data will be also very good. It's a key and very important point to try to validation of about our results and improve them and accuracy of our models. Okay, thank you.
Thank you. That's a very comprehensive response, and I think my curiosity of many participants is already satisfied. Thank you so much for this, and it's great to know how you have used the historical data. The next question is to Mr. Swapnil. We know that Pathways Technologies is basically startup and startup initiatives always use very good high technologies. You talked about ICT high technologies. Do you have any experience with potential of drone in pest management and some relevance to how they can be used in Locust farm? Over to Swapnil.
Yes, certainly. We experimented with the drone technology, and the early indications that we came up with is that what we are seeing is like the understanding and the knowledge with regards to use of the drone and deploying drone technology decides on the knowledge that we have. Use of micro dosages of those pesticides or any bioagents or biochemicals that we could use, or even the pheromones. One critical aspect of the drone technology that also puts the challenges is with regards to the payload capacity. That's why you cannot use drones to a massive degree, to a very large quantity, but then it is compensated by the precision that it provides, because with the mounted cameras that are recognizing these live locusts that are available on the crops, you could actually deploy the pesticides or any other forms of sort of like a treatment to a very specific location. So those are some of the ideas around the drone that we had used in Nepal. And as I was mentioning, that there has to be a more convergence about, because what we feel is that most of the time the startup companies would essentially rely on the authentic information that comes from the other government agencies, and where then the technology and then the knowledge providing institution can actually converge. So these two, if at all they converge, and with the help of farmers, I think there is a great potential even for the young people who are in the audience today to look into some of these emerging technologies and how they can be used for subsequently a massive growing industry in coming future.
Thank you, Swapnil. That's very useful and insightful. I go to now with next questions to Dr. Eric from World Bank. Your theme of your presentation itself was the crisis within crisis. So this year becomes very peculiar because we have COVID-19 and also worst locust attack in last 20 years or 2 decades kind of situation. So any specific thing that you want to point out why what World Bank will do different than routine work on these aspects? And then second thing is you have wonderful products coming out of Agriculture Observatory, but among all the presenters when I look, I didn't see any integration with your products, although these products are very useful for locust monitoring also. So how this can be achieved? So if you can give a response in 1 minute, thank you so much.
Very good. Thank you very much. Thank you for the question. It's interesting that, you know, as all of our presenters have highlighted, this problem, for whatever has been done over the many decades, it seems to recur with frequency. And indications are that as changing climate begins to impact different regions, we will see probably new areas of infestation possibly emerging. This is something that in the Ag Observatory we are tracking, and that last slide that I showed was highlighting how in comparison with historical data over the last 15 years, we are seeing some very significant changes in agroecozone boundaries, which would suggest then a changing potential for infestation in new areas by not just locusts, but a whole range of other pests. So this is something we're working with all our country clients to give them the opportunity to harness this high resolution weather data, because as it was illustrated in the presentation, this is a 9 by 9 kilometer grid, and almost, so that gives us for the whole of Africa about close to 300,000 virtual weather stations, producing the whole suite of weather data, not just rainfall like chirps give you, but min-max temperatures, relative humidity, wind speeds, and other weather variables that are important, derived variables such as precipitation over potential evapotranspiration. So in short, building the national capacity and local capacity to harness this data and then deploy it for predictive and decision support. And so this is a game changer as far as we're concerned. We're not just providing the finance, that $500 million goes into exactly this capacity enhancement. And then to finalize, I think is the organization. So there's this saying that, you know, we're drowning in data but starving for knowledge. And yes, we are all generating this data, but how is it become useful, and how does it support farmers, logistics, policymakers to act early warning, early action, and then continue to monitor this as the actions and impacts evolve over time. Climate change is coming. COVID is a crisis, but we see climate change as an even bigger crisis, and that's something we're going to have to work very hard with in collaboration with all of you. Thank you. Thank you.
Thank you, Eric. Otherwise, it's crisis within crisis within crisis when you bring climate change. Right. So yeah, that's wonderful. Thank you so much. I think it will benefit a lot. People know about this observatory and would integrate your products, and probably they will communicate with you, some of you. Thank you so much. I mean, I just have one more question, and then we are going for very wonderful insight will be provided by Keith Christman. There was also a question for him, somebody, that are these India and Pakistan colleagues using Keith's methods? So he's very well-known authority. So we would go for him. Just wait for 1 more minute. I just have one question to our colleagues from Pakistan. And it's a combined question to Ibrar from Suparco and also Iftikhar and Sara. There was curiosity in the among the participants, and which I received through registration. They were asking that how really practically this integration of field data and satellite images is done and available to the government, because WF is good at collecting a lot of field data, vulnerability analysis, and Suparco has the satellite images. So maybe you can give me combined answer, but don't go more than 1.5 or 2 minutes. First, maybe I would like to give to Ibrar and then to Iftikhar or Sarah. Ibrar, please.
Yeah. Hello.
Yeah, you are okay. You are.
Can you repeat the question because I.
Okay, Ibrar. The question is. So Suparco uses a lot of satellite images and products. WFP has very good tool to collect field-based information. Both offices, both people are working in Pakistan. How you see the cooperation and integration to benefit the authorities? Yeah, thank you.
Very good question because managing a disaster like Locust or even the COVID and other biological disaster natural. The convergence between the local departments as well as international organization representation like FAO, WFP. So somehow we have directly, indirectly able to share our information to the local authorities, and what they do is they actually come up with the conclusion or some of better information which they apply to the field. So, but right now, what we are doing is like we are giving the services to the relevant department like Ministry of Food Security by coming up with solution based on satellite data only. And what they request from WFP and from FAO to give their expertise and converge into a knowledgeable solution. For example, today early morning I received a call from someone from ADB that FAO has some expertise and World Bank has already, I think, committed some finances for procurement of the equipments, procurement of pesticide, the training, and I think from this Locust information system of FAO, they are actually converging at that level. So each department for me, as far as is contributing to the solution, but at right now I don't think so. Okay, that we are able to come up with the joint solution instead of we are contributing to the services or internal solutions.
Thank you. Thank you, Ibrar. I think we will also give chance to Iftikhar. Iftikhar, below 1 minute, please. We are turning late.
Thank you, Suresh. I would say that actually this idea is not new for World Food Program. The integration of the space-based solution with the field data. We have in the past we have done this. For example, during the emergency of 2005 of earthquake and then 2010 super floods. We have the analysis from the UN set data, and then we integrated that information with the field-based information. And particular to this Locust, as I mentioned in my presentation, that we are going to have Locust damage assessments, and for that we have a food and agriculture working group platform where the government is the part of that platform. And Suparco is also the member of that working group on that. And we will be presenting the data based on our field information, and Suparco will be coming, Suparco and another government department will be coming with the data based on the space technology, and through that forum we will be then integrating the information coming from different resources. This is how we will be coming with the integrated product.
Thank you. Thank you, Iftikhar. That's a quite, I think, satisfying response. We are running late, but we have a very important person with us I mean, Keith Chrisman from Food and Agriculture Organization doesn't need any introduction, those who work in the areas Locust forecasting. So I have provided in some of the curiosity questions that we have collected, which he can probably address, and also I request him, he has gone through, now he has been sitting throughout the webinar, And given, Keith, given your global experience in locust prevention and crisis management, what are the way forward to our participants? If you can take the floor, and yeah, over to you, please.
Okay, thank you very much. And I would first like to thank everybody for participating and for the presenters and to this very interesting webinar. So I have a few points that I would like to make. This is based on what we've been doing now for the last nearly 2 hours. First of all, desert locust is a rolling disaster, and we always have to keep this in mind. This is one of the most, if not the most challenging disasters that all of us have to face collectively. It is very different than an earthquake or a cyclone, for example. These are one-off disasters. It's an event that happens, and then we can use a remote sensing imagery to see the before, the after effects, and then we respond accordingly. Desert locust, it doesn't work as cleanly, as simply as that, of course. You know, this is infestations that build up over time, and they distribute themselves and redistribute themselves over time and space. So it's a disaster that can start in one part of the world, and then of course move to other parts of the world, other continents, other countries, in other regions. So, you know, we have to keep this in mind when we're talking about the use of remote sensing and models. So obviously they do need to be global in nature, but we also have to consider the proper resolution. And resolution, especially of remote sensing imagery, it's always a balance with file management. So yes, you can have you know, very high resolution imagery, but then you have a greater number of files and a greater file size to somehow manage in your systems. If the resolution is too coarse, then we're not detecting what we're trying to detect. So I saw in some of the presentations they're using, for example, NDVI data. 1 kilometer data. For desert locust habitats and monitoring the vegetation development, that's not sufficient. We're using MODIS 250 meter resolution operationally, and there's a lot of omission errors. So in other words, it's not detecting that vegetation. So probably for vegetation, as an example, a 100 meter resolution is probably sufficient on an operational basis. We saw some examples of the trajectory model, the high split model by NOAA. Now, those forecasts that go up to a week in advance, that resolution of that is 100 kilometers, of course, using the winds. So there it's quite coarse. The 3-day resolutions are only 25 kilometers, so that's a bit better. We saw some other examples of rainfall estimates, 25 kilometers, soil moisture, 25 kilometer resolution. So sometimes these resolutions are too coarse to detect what we're trying to detect. That's my point. So we need to focus on the optimal resolution. Then, in addition, and we've heard this from a number of presenters, whatever products are produced, they need to be produced operationally, because as I started my comments, this is a rolling emergency. We're monitoring something over time, not just once in a while, but every week, every month, every year. So these products need to be inserted into a production chain that can make these products available operationally and on time, because they are time sensitive. They also need to be in a proper format, such as geotiffs that people can insert into their GIS systems. Because I think the whole point, and this has been mentioned by several presenters, is that we need to integrate, you know, all of our efforts, all of these products, whether they're derived from space or from models, into the national locust programs, who are responsible for managing and responding to desert locust emergencies in their country. In addition, we never should forget that, you know, remote sensing and models are estimates. It's not, you know, the real situation. It's different than, say, let's say a photograph. So we have to use, these products with a certain amount of sense. And we probably need to use them with actual field data, real data. So in terms of that real data, of the ground data, it needs to be standardized if we want to share it globally with different institutes, different countries, different partners. And the best way, of course, to have standard data is to use standard data collection tools. FAO, for example, we've developed the eLocust 3 suite of tools, mobile apps. There's one that works on Android and iPhone. There's one that works on a Garmin GPS. There's another one that works on a tablet connected to a satellite antenna. And there's one that simply works on a web form. So all of these tools have a standard interface collecting standardized data. That makes it much easier to share and to utilize on an operational basis. And we went one step further, of course, as some of you noted. We've made all of these, the ground data that's collected by these tools available freely to the public in near real time through the FAO Esri Locust Hub. So you can download those data sets and use them to help validate, help develop your remote sensing products and your models. But just coming back, we have to use these products with sense. Many of them look beautiful. The outputs are spectacular, and you want to believe them almost with your eyes closed. And we can never do that. Trajectory models, these are the most difficult models to use with sense because their output is usually a bunch of lines on a map showing where swarms have come from or where swarms may go to. But that's not as simple as those maps might depict. Swarms are complex creatures and they have very complex behaviors. They just don't fly on any winds, for example. There were some maps showing that the swarms would move in the northern, from south to north in the Indus Valley of Pakistan, going to Punjab, simply because the winds are blowing that way. But in reality, the swarms would never do that. The swarms would move to the east, to the desert of Tar for breeding. So they wait for the odd day or two, and they then fly on those westerly winds that will carry them east to the desert areas for breeding. And they know that. They know they don't want to go to Punjab, but the model will say that they're going to Punjab. So here you have to be very careful. Similarly, models showing that locusts would continue east across India to Bangladesh and then further east into southwest China. This will not happen. Locusts will not do that. Even if the winds are blowing in that direction, they will not move in that direction because they know better. So we have to use these models, these remote sensing products with experience and with common sense. Then lastly, I would like to just mention one final issue, and that is drones, which is a very popular issue by all of us, also in the media. And there's fabulous potential to harness this technology for desert locust monitoring. The teams that they're going out in the desert, they're a single Land Rover in a huge desert landscape of hundreds of square kilometers. It's, looking for green vegetation and locusts in that huge area is like finding a needle in the haystack. It is very, very difficult. It's a bit of a random exercise. So let's harness, the remote sensing, the models, and supplement that with drones. Drones can be used by the teams in the desert. They could take a portable drone out with them, and that drone can survey up to 100 kilometers and map it, come back to the team, and then the team can go precisely to those green areas that have been mapped. And FAO has been working on this technology now for a couple of years. We're ready to deploy it. We were ready before the COVID-19 restrictions, in fact. So once they're lifted, we'll be deploying these technologies in some key countries that are affected by desert locusts now. That's fine for surveying, for monitoring. They have great potential, drones. But for control, we have to walk cautiously. Nobody knows in the world how to use a drone to effectively and safely control desert locust infestations. So we're going to need to collaborate together to try this out under test conditions, under safe conditions, because remember, we're spraying poisons, we're spraying pesticides, so we don't want to get it wrong. Drones will never substitute other means of control. They will only supplement. So, you know, drones are limited by batteries, of course, by their energy and by their payload capacity. But they can help to control locusts in areas that cannot be treated by aircraft or by ground means. For example, treetops. Sometimes swarms settle in treetops. You can't reach those tree traps with vehicle-mounted sprayers or handheld sprayers, and the area may be too small to spray out by an aircraft. So here, drone has a very specific use. But again, we need to develop standard operating procedures and effective methodologies that can be used with confidence that they will then kill those locusts. So these are just some of the many points and thoughts that I have, but in view of the shortage of the time, I would like to stop here and once again thank all of the participants and the organizers for this extremely interesting and useful webinar. Thank you.
Thank you, Keith. I think your intervention at the last end of the webinar is such a apt. What I could see that there were a series of questions on the chat box, and most of you have already addressed, so we don't have to really revisit those. And you have given very important caution that we should not believe remote sensing outputs with closed eyes. So remote sensing really cannot be done remotely. You should know the ground very well, and you should know the object behavior and everything very well. And also bringing out what FAO is offering with all these technologies, including the drone related technology, very useful, very insightful. And that's the best way of, concluding the panel discussion. With this, we are coming to the end of the webinar. Before that, I would like to first ask Mr. Giriraj, who was working with me for 1 week, putting a lot of efforts to organize this. So Giriraj, do you have any comment before I close the webinar? Over to Giriraj, please.
Yeah, thanks, Suresh. And I don't want to take much further time. We already went ahead with more than 30 minutes. We sincerely thank all the participants and the panelists. And as a take home from this is we will be summarizing all the speakers and as well as some of the questions which are raised. We'll come back with a workshop report of this webinar and post it in our website, and equally as well to share all the presentation and the recorded video today. So there are a lot of interesting messages came from all the speaker speaking about operationally they are available, standardization, looking about a different data set, how do you integrate that with space-based to field-based input. All these points are very relevant. We will come back with more outputs from this webinar as we move on. So thanks again, and pass it on to Suresh to conclude this webinar.
So thank you, Giriraj. And personally, I would like to thank all the panelists who have taken efforts to bring their own research and experiences and to share with all the participants. Participants were very active on the chat window, and also speakers were very actively replying those questions which were posted in the chat. So it has been really taken care. So it was a different ecosystem going on the other side. For me, basically, it was a great learning. So along with all the positive points about how different countries and organizations are using the technology and integrating with field data and also for the policy interventions, there was also realization that we still need a lot of coordination. Many remote sensing related efforts are stand-alone and they are not getting integrated in the mainstream, whereas policies sometimes don't consider what remote sensing community is doing. And this is where I think our webinar has achieved some kind of, I would say objective of, coming together and understanding those lacunas. So I hope with this webinar, we can think of coordinating better and improving our results of our models, and also trying to see that what Keith said is very important. It should be all operational. As crop is growing, we don't have time, and Locust is just developing its stages and getting into converting to SWAP. So we need to really have operational methods, and that reminds me my time in Afghanistan, how I used to monitor opium cultivation. From December to July, absolutely no rest, no opium grows, and we have to just monitor in order to understand how the dynamics of poppy cultivation and all things. So I think that's true for this also. We need to be very operational. So I take a lot of good messages, and thank you all the speakers panelists, and thank you all participants for very actively making this particular webinar successful. And as Giriraj said, that we will try to bring out some kind of report, and this would not be end, but probably this can be beginning of our association. So thank you so much for patience of everybody, and have a good day for several persons and good evening in Asia. Thank you so much for everyone. Thank you for attending this. Bye-bye.
Bye.